A recap of previous classes. In our last class, we discussed about the binary relation. If there is a relation between two entities with the help of relationship set, then it is called binary relation. The relation which is being depicted among two relations, two entities, entity sets, is nothing but it is a binary relation. Also, in our last class, we discussed about the ternary relation, more than two. For example, if there are relations between more than two entities, three entities, let me say employees, they got related to departments, and employees got related to projects. They are executing some projects. Then there is a relation between employee and departments. There is a relation between employee, departments, and project. Then you go with the ternary relation. More than two relations, if you establish, that comes to ternary relation. Example, a student got related to lecturer. Student is one entity set. Lecturer is another entity set. Student and lecturer both got involved in examinations. Examination is another entity set. Student need to answer the examination. Lecturer is to invigilate the examination, or he need to give the question paper for the examination. The student and lecturer both got related to examination. Then the relations between three entity sets, that comes to ternary relation. We discussed about binary relation, ternary relation, and also we observed what is a unary relation. Unary relation is nothing but the relation which is related to itself. The same entity got related to itself, then it is called unary relation. Example, a supervisor should supervise the subordinates. Supervisor is an employee and subordinate is also an employee. Supervisor is an employee and even subordinate is an employee. Then here you are having only one entity. You are having only one entity. The employee is an entity, supervisor is an employee, subordinate is an employee. The employee is related to the employee, that is a unary relation. If entity is related to itself, if the entity is related to itself, that is called unary relation. And also we had the instance diagrams. We take some sample data coming to the instance diagrams. After drawing ER diagrams, entity relationship diagrams, we take some sample data. And we work out on the sample data, testing the mapping cardinalities. That is an employee, for example, we take 101 is an employee number, 102 is an employee number, 103 is an employee number, 104 is an employee number. These are instances. If you take some sample data, that's called instances. And these employees are working for some departments. Let me say department number 10, department number 20, department number 30. Now, the employee number 101 got connected to department number 10. 101 also got connected to department number 20. If I am taking some sample data and I am depicting in the form of diagrams, then it is called instance diagrams. We call it as a instance diagrams. And also we had a discussion on mapping cardinalities. That is one-to-one relation, one-to-many relation, many-to-one relation, and many-to-many relation. There are four types of relations, mapping cardinalities: one-to-one relation, one-to-many relation, many-to-one relation, and many-to-many relations. These are called mapping cardinalities. We discussed about weak entity set. A weak entity set is a set which don't have primary key. A weak entity set is a set which don't have any primary key. You can't find any primary key for the weak entity set. You will not find any primary key for the weak entity set. A weak entity set is always dependent on strong entity set. And also it is explained for you, the weak entity set is depicted with the help of double rectangular boxes. We go with a double rectangular boxes for weak entity set to depict weak entity set double rectangle box, or we write a thick line, very thick, dark rectangular box. So weak entity set does not have any primary key. A key is nothing but with which you can identify an entity from the entity set is nothing but is a key. For example, student number is a key. There will be number of students and the names may get duplicated. The student names may get duplicated. Then how to identify a student? With the help of key. The key is nothing but your roll number. With the help of roll number, we are able to identify the students. That is nothing but it is a key. A key is that with which you can identify an entity from the entity set is called as a key. For weak entity sets, you will not find any key. You will not have the primary keys. We had a discussion on key constraints. There is a discussion on key constraints. Key constraints, that is nothing but the keys are being represented. The keys are being represented with a underline. In the attributes, we draw underline. In attributes, we draw underline for the key attribute. So we put an underline for the attribute. That's nothing but it is called as a key constraint. And also we discussed about hierarchy, class hierarchy, generalization and specialization. For example, employee. It is a generalized term. It is a generalized term. I'm saying it is an employee. He is an employee. That is a so generalized, broad term. It is a high level. And I want to specify that employee is a daily wage worker. That daily wage worker is a specialization. That employee is a, that is called is a relation. That employee is a contract employee. Is a contract employee. So is a contract employee, if I am saying, that is a specialization. If I just say employee, that is called generalization. If I give further classification, that employee is a contract worker, that employee is a daily wage worker, that employee is a regular worker, then we are saying that they are specializations. The concept is called specializations. And generally in programming languages, we make use of the superclass subclass relations in order to depict this class hierarchy. In order to depict the class hierarchy, we go with the superclass and subclass relations. The class hierarchy is being depicted with the help of superclass subclass relations. Aggregation. Let us have a discussion on this aggregation. Aggregation is nothing but sometimes we combine entities and relationships. We club entities and relationships. And for that clubbed unit, I'll be establishing a relation. Then we say it is an aggregation. For example, every department should execute some projects. So if there is a department, definitely there will be a project. It is if there is a department, departments are meant for developing the projects. Then I aggregate departments and projects into a single unit. That's called aggregation. I'm clubbing the departments and projects into a single unit, which I'm calling it as aggregation. Now for this aggregated unit, employees will be working. Employees will be working for the aggregated units of projects and departments. Aggregated units of projects and departments means employees are working for projects as well as departments. That is aggregation. When you are clubbing different entities and relationships into a unit, and if you are establishing relations to that unit, then it is called aggregation. This is what we discussed in our last class. And in today's class, the output, the outcome of today's class, the expected outcome of today's class is entities versus attributes, relation versus entities, attributes on relations, binary versus ternary relations, aggregation versus ternary relations. These are the topics we are going to discuss, and the outcome of today's discussion should be this: entities versus attributes, relations versus entities, attributes on relationships, binary versus ternary relations, aggregation versus ternary relationships. We are going to cover these topics, and today's outcome should be this. These are the bulletin points, the outcome of today's topic. Let us start today's discussion. Entity versus attributes. Entity versus attributes. Sometimes when we draw ER diagrams, we represent some attributes. We'll be drawing ER diagrams. For example, I'm drawing a diagram. This is an entity of employee. Let me say this is an entity of employee. I'm calling it as an employee entity. This is an entity of employee. For this, I'm putting attributes of employee number. I'm putting attribute employee name. I'm going with an attribute address and so on, salary and address. So for entity, I'm putting attributes. I'm drawing some attributes. Now there will be a confusion sometimes. Certain items should be represented either in the form of attributes or in the form of entities. we get a doubt whether certain items should be considered as attributes or entities. Listen carefully. Entities versus attributes. And coming to this entities versus attributes, while drawing ER diagrams, we get a big doubt whether certain items should be considered as an entity or as an attribute. Example, if I take employee, I'm having employee number, that I'm taking it as an attribute. Name, I'm taking it as an attribute. Salary, I'm taking it as an attribute. Address. Now I got a doubt whether address is to be considered as an attribute or another entity. Whether address is to be considered as an attribute of employee entity or a separate entity. Why means the address, it internally comprises many other things like door number, street number, street name, city, pin code. When I say address, the address internally comprises lot many things. Then I will get a doubt whether address is to be taken as an attribute or it is to be considered as an entity. That is a big doubt. Depending upon the importance of address, depending upon the importance of that particular item, we need to consider it either as an attribute or as a separate entity. We'll study an example that will be more clear. You observe here employee. I'm designing employee entity. You observe the design. I'm designing employee entity. I'm taking employee number. Good. It is an attribute. Name. It is an attribute. Employee name is an attribute. Salary. Let me say this is a salary. Salary is an attribute. Employee number, name, salary. These are the attributes. Quite comfortable. I'm taking address as an attribute. Now I got a doubt, because why I got doubt means address, it internally comprises a door number, street number, city, pin code. This address internally contains a lot many sub attributes. Then there is a doubt whether to take address as an attribute or a separate entity. The same thing, the same diagram I am depicting like a separate entity. Here address became an attribute. In this case address became an attribute. Now you observe here this diagram. Employee, it contains employee number, employee name, and let me say this is salary. Employee number, name and salary. This is employee number, name and salary. Employee number, name and salary. And also I want address. Has employee, has address. I am taking address as a separate entity because address, it internally contains door number, street and city. If you are very particular about each and every item of address, and if the address is playing a predominant role in your database designing, then better you take address as a separate entity. Once again, you listen carefully. In your database designing, if you feel that address plays a predominant vital role, a big role, and the details of address is must, each and every attribute and item is very, very important, and address plays a vital role in your project, in your database design, then better you take address as a separate entity, and for this you give door number, street, city, pin code, state, etc., etc. Suppose in your database you feel address is not that important and there are many other things which are to be focused. Address is not that important and there are many other things which are to be focused. Then you don't take address as a separate entity. You take it as an attribute. You take address as an attribute. Sometimes an employee may have multiple addresses. Address 1, address 2. A permanent address, a temporary address, office address, something like that. Sometimes an employee may have multiple addresses. He may give his permanent residence. He may give his temporary. Sometimes I will be there, sometimes I will be here. In such cases, if you want to preserve all those details, then better you take address as a separate attribute. A separate entity, as a separate entity, not as an attribute. Take address as a separate entity, not as attribute. So it depends upon the problem and situation. I hope you are following this, right? Entity versus attribute. If that particular attribute is having a vital role, a predominant role in your database design, then you take that attribute as a separate entity, not as an attribute. This is the point you need to observe. Now, relation, let us have a discussion on relation versus entity. Relation versus entity. You observe this point carefully. Relation versus entity. Employee is a entity. Department is an entity. Employee are working for departments. The employees are working for departments. Okay. Employees are working for departments. Listen carefully. From when they are working for department. This is called relationship set. This is called entity set. Employee is an entity set. Department is an entity set. The employees are working for departments. They are working for departments. And from when to when they are working, I want the details. From so and so date to so and so date, they are working for so and so department. So from and to are not related to either employee or department. They neither belongs to employee entity nor belongs to department. They belong to both. This department is having the services of these employees from so and so date to so and so date. Or in other words, I will say the employee served the department from so and so date to so and so date. Both requires this information. Both employee as well as the department, they require these attributes from when to when. From when to when. Okay. The employees are working from so and so date to so and so date to so and so department. In other words, in the reverse direction, this department utilized the services of employee. The department utilized the services of employee from so and so date to so and so date. Means this from and to both are required for department as well as an employee. And hence I'm putting these attributes on the relationship set. Now the point is, if these attributes gets increased, in this example there are only two attributes. Sometimes you will get more attributes. This is another attribute, this is another attribute, this is another attribute. You will get a hell of attributes. If attributes are increasing on relationship set, listen carefully, listen carefully. If attributes are increasing on relationship set, then better you create a new entity set with all these attributes, with the attributes which are depicted for the relationship set. You observe this example, employee, department. From to, I am removing from the relation. I am removing from the relation. And what I am doing, I am creating another entity called duration. For this duration, I attach the attribute from and to. Employee works for the department. For the duration, I am taking duration as a separate thing because the duration it contains from date to date, etc. etc. Lot many things it may have. And hence all those extra attributes I am removing and I am creating a new entity set. I am creating a new entity set with from and to concepts, from and to concepts. This is nothing but relation versus entities. And coming to relation versus entities, both are correct. This is correct, this is also correct. The situation when the relationship set contains more attributes, if it is one or two attributes, it is okay. If the relationship set contains more attributes, then better. All those attributes you remove from the relationship set and you form a new entity set. That is the reason this diagram can be better depicted like this. The same diagram can be depicted like this. Employees, they are working for departments. The employees are working for the departments and the employees are working for the departments for the duration, for the time period of from date to so and so date. I hope all of you are following the class, right? Attributes on relationship. Let us go ahead with the topic attributes on relationship set. Attributes on relationship set. You observe this carefully. Let us directly go with the diagram. Employees are working for departments. Employees are working for departments. Since so and so date they are working with some budget. With some budget they are working on for the departments. Every department is having department number, department name and budget. You observe the diagram carefully. You just observe the diagram carefully. This is salary. Okay, let me say this is the salary. Every employee is having employee number, name and salary. Employee number is underlined. Underlined means it is a primary key which is not duplicated. Employee number is underlined. Underlined means it is a primary key which is not duplicated. With this, I can identify entity from the entity set. Employee number, name and salary. This is employee. There is a department entity set. This is called department entity set, which is having department number, name and budget. The departments are identified by department numbers. Departments are identified by department number. And these employees, the managers of the employees are given budget. They are being allotted with budget. That is called discretionary budget. D budget means a discretionary budget. Discretionary budget. Discretionary budget means this budget is to be spent by the managers of the department for the welfare of the department from, they will fix a date, from 2001 January 1st to December 31st, 2020. So they will fix some date, some period. In that period, for the welfare of the department, they need to spend the budget by the managers. Once again, I am repeating the question here, what is being specified. I am repeating. Employees are there, they are working for the department. In these employees, there are some managers. For managers, some amount is given to spend for the welfare of the department, which is called as discretionary budget, D budget. I specified it as a D budget, stands for discretionary budget. Some budget is given, some amount is given for the welfare of the department. And they are asked to spend that from so and so date. They gave some date. From 1st January 2020 onwards, you start spending that. Or 1st January 2019 onwards, you need to spend this budget. They gave some date. For which I had drawn a ER diagram like this. This is the entity relationship diagram. Employees are working for departments. Manager is also an employee. And generalized, I had drawn the ER diagram that employees are working for the department. Every employee is having employee number, name and salary. And department is having department number, department name and budget. And coming to the managers, since so and so date, so and so amount of budget is to be spent. This is nothing but a discretionary budget is to be spent. This is a generalized ER diagram. This generalized ER diagram can be enriched, can be enhanced, can be depicted in a better way. This ER diagram, the same ER diagram, can be depicted in a better way, like with a easy relation. What is this easy relation? You observe carefully. All employees are not given budget. Only the managers are allotted budget, but manager is an employee. Here this ER diagram, coming to the problem with this ER diagram is, all employees are given budget. This is the meaning of this ER diagram. All employees are given budget. That becomes the meaning of this ER diagram. No, not all employees. Manager is given the budget and manager is an employee. That is the reason I am showing the ER diagram like this. Employees. Employee are managers, workers. The employee, coming to the employees, employee number, name and salary. Let me say this is salary. Employee number, name and salary. And employee is a manager and workers. Workers are not given budget. Manager is given budget. Only manager is given budget. That is the reason the budget attribute is D budget is added to the manager. Only managers are given budget and hence the D budget is given to managers. The managers manages the department. They manage the department by spending necessary amount. So managers are managing the department, not workers. Workers are not managing. Manager is managing the department. Every department is having department number, name, department number, department name and budget. And for this department from so and so date, they need to spend the budget. The budget is allotted to managers. The budget is given to the handoff. It is being handed over to the manager. That is a D budget is handed out to the manager. And for the department, they need to spend since so and so date. So this same ER diagram can be depicted like this. This is a better ER diagram when compared to this ER diagram. Both are correct. There is nothing wrong. But this is a generalized ER diagram. This is a very pinpoint, specific, accurate ER diagram. Just a minute. Once you go through this two diagrams, please go through two diagrams. The question is like this. The question is, the employees are working for department. So employees are managing the department. And for employees, some budget is given and they need to spend this budget from so and so date. That is since from so and so date, the department budget, that is called discretionary budget, is to be spent for the department. Here the point to be observed is, every employee is not given the discretionary budget. The budget is handed over to the manager of the department. For a department, there will be one manager. The budget is handed over to the manager, and it is the responsibility of manager to spend that budget. It is the responsibility of manager to spend that budget from the specified date. I had drawn a ER diagram like this. Employees are working with, employees are working for the departments, employees are working for the departments. And some budget is given, they need to spend this budget for the departments. These employees should spend this budget from so and so date for the welfare of department. This is the diagram. Of course, this is a right diagram. But to be precise diagram, still accurate diagram is, for all employees, this discretionary budget is not given. Only the discretionary budget is handed over to the manager of the department. And of course, manager is an employee. Manager manages the department. Now you observe the diagram. Employees is a, I am going with is a relation. Employee is a manager, worker. All employees are not given discretionary budget. The amount is not given to the hand of all employees. The budget is given only for managers. The budget amount is handed over only to the managers. And hence, the budget is an attribute which I am taking only for the managers. In employees, there are workers and managers. And budget is given only for managers. And the discretionary budget is an attribute of manager. So, every employee is having employee number, name and salary. Every employee is having employee number, name and salary. But managers is having, apart from salary, he is given some budget, discretionary budget. He should not use that for himself. It should be used for department. This budget should be used for the department. And he need to use only from the specified date. Since, let me say 2019, January 1st, he should use for the department. This budget amount is handed out for the manager, not for the workers or other employees. And hence, I had depicted the same diagram like this. This is a better diagram when compared with the previous diagram. Yeah, you please go through this for a minute. Have you gone through? For example, I am taking, let me say there are some machinery. The machines are used to complete projects. I am taking machinery. The machines are used to complete projects. Right? Every machine is having machine number, machine name and some life of machine. 2 years. This machine works for 5 years or whatever maybe. The life of machine is having, every machine is having machine number, machine name and life of machine. Here you are having a project number, project name and number works on the project. Number of employees works for the project. Right? And this machinery are used for the promotion or the completion of the project. But in machinery, there are some varieties of machines. Machine type 1, machine type 2. Machine type 1 is indoor machine, machine type 2 is outdoor machine. Let us think so. So in machines, you are having two types of machines, which works inside, which works outside, which is working for outside. Means there are specialization. The machines are of two types. There are indoor machines and outdoor machines, which work outside, outdoor machines. So this is nothing but a specialization. Mission is a generalization. Mission is an indoor mission. This is a specialization. Mission is an outdoor mission. This is a specialization. Only for outdoor missions, we need some workers. For outdoor missions, we need some extra workers, not for all missions. Then extra workers is being assigned to outdoor missions, not for indoor missions. Extra workers are required for outdoor missions, not for indoor missions. Are you getting it? So the attributes may not be common for all missions. There will be some specialized attributes. There may be some specialized attributes, and in such cases you need to specialization. You need to go with the specialization of the relation. Specialization of the relation. And now these outdoor missions with workers attributes, missions plus workers, are working for the sake of projects. They are working for the projects. This is a better diagram when compared with this diagram. For example, I'll say students. The students should be given special class. After 4 o'clock, for students I need to give special class. Student is an entity, special class is an entity. For students we should give special class. Okay, we'll draw the diagram. Now what I say is, only for slow learners, you listen to the question carefully, only for the slow learners we need to give special class. I need not give special class for all the students. I should give for the slow learners only. I need to give the special classes. Then the students are being divided. Student is an entity set which is being a. Student is a. Again I am categorizing the student as a fast learner, slow learner. I will categorize as a fast learner, slow learner. Fast learner and slow learner. For the slow learners, I will relate. For the slow learners, I will give special class. This is the entity of special classes. The special classes are given for slow learners, and slow learner is a student. Student. The student is a slow learner. Student is a fast learner. For slow learner, I am relating the special classes. I am giving special classes, not for all students. This is a better diagram just by instead of saying all students should be given special classes. Are you getting it? So this is attributes on relations. Yeah, that is attributes on relations. On relations, we give some attributes and we go with some specialization concepts, and we draw the diagrams, ER diagrams. Mega projects, you need to do big projects. While doing the projects, you need to go with the database design. While going with the database design, first you need to draw rough diagrams like this. These diagrams are called ER diagrams, entity relationship diagram. A conceptual based ER diagrams you are going. Now let us go ahead with binary versus ternary relation. Binary versus ternary relation. Sometimes we depict the diagrams in binary form. Sometimes we depict the diagram in ternary forms. Ternary and more than two. More than two is ternary. Only two is binary. Binary relations, ternary relations. Sometimes binary, sometimes we go with the ternary relations. That depends upon the problem statement what we take. Just we will discuss this binary ternary relation by taking an example. You observe here the requirements can be fulfilled better with binary relation rather than ternary relation situationally. The requirements can be fulfilled better. The requirements can be fulfilled better with binary relation rather than ternary relation. Sometimes binary relations are better than ternary relation. Sometimes binary relations are better than ternary relation. You can depict it in a better way. How that we discuss with an example. Just we take an example, we'll go through that. You observe here, you observe this diagram. Employees purchases policies, insurance policies. Employees purchases insurance policies for the dependents. Means when the employees are working in factories, they will insure their life. They take some policies, life insurance. They take some policies. They purchase some policies for the sake of dependent. Suppose in the factory, if something wrong goes on for the employee, some disaster occurs and something happens for the employees, then the policy amount will be given for the dependents, for the wife, children, their parents. The policy amount will be given to the dependents. Now, coming to this diagram, we depicted this diagram like this with a ternary relation. We depicted this diagram in a ternary relation. Employees are having dependents, and these purchased the policy amount. And of course, the dependents is a weak entity set. It don't have primary key. It is a weak entity set. It should be depicted with a thick line. It is depicted with a thick line. This is a ternary relation. Of course, this is right. There is nothing wrong in this. But this can be better depicted in a better way. You can show with the binary relations rather than ternary relation. You can better depict in the binary relation instead of ternary. Here in ternary, there is only one relationship set which is connecting this entity, and entity. All these entities are being connected with a single relationship set. Now, we are going with the binary relation. You observe here, employees, purchases, policies. Employees, purchases, policies. In the sense, every employee, it is a must. Every employee, you can put an arrowhead here. Either here or here, makes no difference. Every employee will purchase many policies. The meaning of this diagram is, if there is an arrowhead, that implies every employee, each employee. Here you don't have arrowhead. Each employee purchases many policies, insurance policies. He will take health insurance, he will take life insurance, he will take accident coverage. He can take many policies. That's the meaning. Each employee takes many policies. And each dependent, arrowhead, each dependent can have many policies because employee is having many policies. If anything goes wrong for the employee, all these policies can be used by dependents. So the dependents, each dependent is having many policies. Many policies is having. Is it okay? So this diagram can be briefed, can be sketched in a better way like this. Here we are showing with the ternary relation. Here you are showing with the binary. See here 1, 2, 2 relations. And coming to this 1, 2, 2 relations. There is a relation between dependents and policies. This is the relation between the employees and policies. Only two entities are getting connected. For this relationship set, this is 1, this is 2. Two entities are connected. Here if you see in this direction, this is 1 and this is 2. Two are getting connected. Whereas here, this relationship is connecting with 1, 2 and 3. It is getting connected with 1, 2 and 3. This is ternary relation, this is the binary relation. So sometimes, not always, sometimes depending upon the problem, the binary relation is better. It expresses better meaning than ternary relationship. The binary relations expresses better meaning than ternary relationships. That is a point to be observed. Dear students, just 1 minute, you go through the diagram. Aggregation versus ternary relation. Sometimes we group the objects and show, sometimes we separate the objects and show. Grouping the objects, I told you previously, grouping the entities as well as the relationship sets comes to aggregation. Sometimes we are forced to group, sometimes we don't group the objects. Ternary relations. Binaries, that is aggregations and ternary relations. You observe the point here. You observe the point. You take this diagram. We'll take this example. Here I am aggregating. There are projects which are being executed by the department. There are projects which are executed by department. and employees are working with this department and projects until. Means there is a specific date. This employee should execute this project till so and so date. Here you're having until. Till so and so date, until so and so date, the employee should work for the department and projects. Compulsory. Let me say till 2021. The employee should work in so and so department with so and so project. That is assigned. Department as well as project. Department as well as project is being assigned until, let me say, 2021. Some employee should work for department number 10 and so project till 2021. Suppose until it is being specified. Then what I am saying, he is forced to work with this department and this project only till 2021. It is fixed until 2021. It is fixed. In such cases, definitely this employee should work with this department and this project only. Then you aggregate these two. These two you aggregate, and I am saying the employee is monitoring these departments as well as this project until 2021. I am aggregating this using aggregation. Suppose if this is being depicted like this, the employee can work with the departments. The employee can work with projects. I am not specifying until. I am not specifying definiteness. Till 2021 only he should work with this both. I am not specifying. Employees should work with some departments. Employees should work with some projects. I gave some liberty. I may be with the 10th department till 2021. I may work with this project till 2023. So I am not very specific. Till 2021 you should work with this department and only with that project only. I am not saying that. When that sort of leverage is given for the employee, then you need not aggregate. You need not aggregate projects and department. The employees works with the departments, employees works with the projects. This is a ternary relation. I am not aggregating. I am not clubbing these two. Projects and departments I am not clubbing. I am just separating. I am freeing them because these two are not dependent with until and so and so. There is no rigidity. As there is flexibility, I am not aggregating. I just left it. So this is with aggregation, this is without aggregation. This is the ternary relations. Aggregations, and this is the ternary relation. This is what? Just a minute, you go through, and with this we conclude. Dear students, you please go through all these topics and we continue our class. The next class we continue, and stay safe, stay healthy. Have a wonderful day rocking. Goodbye.